Hello, and thank you for tuning in today. My name is Matt Corniss. I'm a fish biologist with the U.S. Fish and Wildlife Service's Green Bay Fish and Wildlife Conservation Office and a scientist with the Great Lakes Coated Wire Tagging and Recovery Program. I'm here today to provide a very quick update on our program's activities for 2020 and some details on the post-release movement of hatchery-reared lake trout in Lake Michigan. Regarding 2020, our program was successfully able to tag all lake trout at federal hatcheries in the fall, per normal, and we were able to assist with one state Chinook salmon and steelhead project in the spring before pandemic precautions took hold and kept us out of the field for much of summer. We also successfully completed a thorough review and proofing exercise of all prior year's data to assure the highest possible quality in our databases. Although we were unable to provide a sport fishery survey in 2020 due to the pandemic, we do aim to be back out there this year in 2021. We also determined that one key metric from our survey, the estimation of wild Chinook salmon production for each year class, can be conducted at age 2 for the 2019 year class this year, based on a retrospective analysis showing high correlation between estimates done at age 1 and 2 for prior years. Another success was finalizing our report on a new lake trout movement matrix, and that is going to be the bulk of the talk today. I do want to recognize up front that the data collected for this study in large part came from the Lake-wide assessment plan, and recognize that this would not have been possible without our state and tribal partners who participate heavily in that survey. So lake trout have been the focus of rehabilitation efforts in the Great Lakes since the 1960s through stocking and controls on mortality, including harvest regulation and the Fish and Wildlife Sea Lamprey Control Program. This is a figure showing the commercial yield of lake trout dating from 1910 through 1960 in Lakes Michigan, Superior, Huron, and Ontario, and shows that the collapse of the lake trout occurred in the late 1940s and early 50s in these lakes. Since that time, multiple genetic strains of lake trout have been stocked to promote genetic diversity, use of varied habitats, and resilient responses to change. This figure is showing the number of lake trout stocked in terms of yearling equivalents by year class, and the main thing I want folks to get out of this figure is the diversity of strains that have been stocked. Each one of these colors represents a different genetic strain. So movement among interconnected regions is important for understanding and assessing fisheries stocks, and updated movement data on lake trout are needed to address several management objectives. These include defining stock assessment units, particularly in the non-treaty waters of Lake Michigan, measure the rates of movement between stock assessment units, determine what fish contribute the most to the fisheries, and to help understand the genetic origin of wild fish. Lake trout movement was last assessed in Lake Michigan by Elliott 2003, and although this provided solid data on lake trout movement, it had to rely heavily on assumptions from the literature due to limited tagging. At this point in time, coated wire tags were only used on a few select priority locations, and most lake trout stocked in the lake did not receive a tag, which meant that the stocking location was unknown, and movement had to be assumed based on literature values. However, starting in the 2010 year class, all hatchery lake trout released into Lakes Michigan and Huron have received a coated wire tag and an adipose fin clip, allowing a fresh evaluation of movement from the Great Lakes Coated Wire Tagging and Recovery Program. To that end, regarding tagging and tag extraction, all hatchery fish receive adipose fin clips and coated wire tags using an automated system capable of processing 7,000 to 10,000 fish per hour. There are some photos of this system below. The upper left corner shows an exterior view of the tagging trailer, and the bottom right corner shows an interior view where you see multiple lines where fish enter to get fin clipped and tagged. The tags provide data on the stocking location, year class, and genetic strain of each of these fish, and all lake trout, between 3.8 and 6.3 million fish, are tagged annually since 2010. The recovered coated wire tags are then hand extracted from samples collected by gillnet and sportfish surveys. And we used both of these survey types in our assessment of lake trout movement. Fishery independent surveys have been conducted since 1998 through a coordinated interagency effort to annually assess and sample lake trout. This is the lake-wide assessment plan that I referenced earlier. Through this effort, graded mesh gill nets set in 8 different mesh size increments to collect a wide variety and different sizes and ages of fish are set on bottom each spring from April through June. And we were able to collect over 8,500 coated wire tag lake trout from the mass marked cohorts for this study on movement. The map here on the right shows the sampling locations for these fishery independent gill net surveys in both Lakes Michigan and Huron. We also relied on data collected from the sport fishery. Since 2012, there's been an extensive field survey on the U.S. waters of Lake Michigan and Lake Huron, coordinated by the Fish and Wildlife Service and state partners. This survey collects angler-caught fish. We employ 6 different teams that sample over 40 ports and 15,000 fish each year. This map on the right shows the home base cities of these 6 sampling teams as black stars and all of the sampling ports as red circles. We were able to collect over 4,600 coated wire tag lake trout from the mass marked cohorts for this assessment on movement. In order to combine these methods, the results from both surveys were expressed as a catch corrected for effort, and we looked at the percentage of fish that were moving from each stocking location to each of various management units in Lakes Michigan and Huron. The map on the left shows management units in Lake Michigan, indicated by 2-letter codes and a number, WM4, MM6, for example. We also treated the 2 refuges in Lake Michigan as separate independent units. These include the northern refuge and the southern refuge in the northern and southern parts of the lake, respectively, shown by the red polygons. Results from both of these surveys were averaged for each management unit where possible, but some units, like these refuges, where there is no permitted sport fishery, were assessed from a single survey. So the first objective of this study was to estimate the percentage of lake trout moving among management units post-release from the mass marked cohorts, which was the 2010 year class through present. To that end, I'm going to show results through a series of maps, and to orient you to these maps, each map will show the stocking location of these fish as a highlighted yellow area. Then the percentages of fish that moved from that area to each different unit around the lake is indicated by a percentage value. These should add to 100% plus or minus 1 due to rounding error for each map. So in this first slide, we're looking at the results for lake trout that were stocked in northern Lake Michigan. The slide on the left shows lake trout that were stocked in the northern refuge largely stayed within the northern refuge and adjacent units. About 36% stayed in the refuge, with about 25% moving both east and west to the nearshore fisheries in MM2 and MM3. The remainder of these fish migrated southward into Wisconsin and Michigan nearshore waters down to about the midpoint of each shoreline. By contrast, lake trout that were stocked in non-refuge waters of MM3, shown on the right-hand map, were much more localized in their importance than those stocked on the offshore refuge, with 72% being recovered in those same non-refuge MM3 waters. We did see some movement of those fish from non-refuge MM3, but it wasn't the same extent as we saw from those stocked offshore at the refuge. Moving farther south in the lake, we're looking now at lake trout stocked in Grand Traverse Bay on the left. That's management unit MM4. And we can see that most lake trout stocked in MM4 remained in MM4, with some fish moving outside of Grand Traverse Bay, but staying in the adjacent units. On the right-hand side map, we see fish stocked in MM5 near Frankfurt. And again, most of these fish were recovered in the same unit where they were stocked, close to 50%, with another quarter of those fish being recovered immediately south in the next unit. One interesting trend we noticed with these nearshore stocked fish is that there did tend to be a movement south rather than north. So as you can see, more of these fish stocked in MM5 moved south than north. Only about 11% were recovered north of that stocking location, compared to 40% that were recovered south of that stocking unit. Again, moving south, we're now looking at fish stocked in southeastern Lake Michigan. On the left, we see fish that were stocked in MM6 near the Little Manistee River. And once again, we do see most of those trout being recovered in the unit where they were stocked or in adjacent units. And again, we see this trend of southward movement, where fish that did leave MM6, only about 11% were recovered north, compared to over 50% recovered south. On the right, we're looking at fish that were stocked in MM7 and 8 combined. We weren't able to separate these two management units because the tag code stocked there spanned both units. And we did see that 80% of the fish stocked there were recovered in that same unit. Moving on to southern Lake Michigan, we look at, on the left, fish stocked in Illinois. This map looks a little bit different, and the main reason for that is that most of these fish were stocked offshore at Julian's Reef, which is in Illinois waters. Because these fish were stocked offshore, they do seem to have a little bit of a wider reach in terms of their movement. We did still see over 55% of these fish retained in the southern part of Lake Michigan, in Illinois, Indiana, and southern Michigan waters, but the remainder of those fish did move northward and were recovered on both shores of the lake, as well as 10% being recovered within the waters of the southern refuge. On the right, we look at lake trout that were stocked in Indiana, and again, we see fish mostly recovered in the southern part of the lake. Lastly, I have results for lake trout that were stocked in the southern refuge. And while we saw over half those fish recovered there in the southern refuge, the other half were really broadly distributed across the southern 2/3 of the Lake Michigan basin and contributed to fisheries on both the Wisconsin and Michigan shorelines, as well as Illinois and Indiana waters. To touch real briefly on lake trout stocked in Wisconsin waters, throughout this effort we only recovered 16 lake trout that were stocked near shore in Wisconsin. Part of this is because lake trout stocking in Wisconsin waters was discontinued several years ago, and those that were stocked from 2010 through I think 2013 or 14, for whatever reason, did not have a high recovery rate or a high survival rate. Of these 16 lake trout, 55% were recovered in Wisconsin and 40% in Indiana, but we don't have a formal map here because that is a really low sample size on which to make inference. So to sum this all up, how much do lake trout move post-release? It turns out that the dispersal range of lake trout is limited to about 100 kilometers or 62 miles. That's taken from this figure below, which shows on the y-axis the cumulative proportion of lake trout catch per unit effort as a function of the distance from the stocking location where those fish were recovered. In this figure, we only plot data for the 3 offshore locations. This is because we observed the greatest amount of movement and dispersal from fish stocked at these offshore sites. These include the Northern Refuge in purple, the Southern Refuge in blue, and Julian's Reef in Illinois waters in yellow. What we're seeing on this, if you look at that red dotted line, that shows where each of these proportion figures intersect with 100 kilometers. And we can see from this that between 72 and 82% of lake trout stocked at these 3 locations were recovered within 62 miles of the stocking location. So there were the occasional lake trout that moved farther than that, but the vast majority were recovered within this home range. We were also able to utilize the genetic strain data within the coded wire tags to look at strain-specific movement. Most of the genetic strains stocked into Lake Michigan exhibited similar movement patterns, but one genetic strain, the Superior Klondike strain, had much less movement than other strains. So on the left, we were looking at a dispersal of Superior Klondike strain lake trout stocked on the Southern Refuge, and the circles in the map represent are proportional in size to the catch per unit effort. You can see a big blue circle in the middle of the Southern Refuge, indicating that most of these Klondike fish, which were stocked on the Southern Refuge, were recovered there, and only 3% were recovered off refuge. By contrast, the Seneca Lake strain fish that were also stocked on the Southern Refuge had a much higher dispersal rate, with 72% being recovered in nearshore waters. On that map on the right, you see that most of those circles are smaller, but they are more broadly dispersed, indicating that the total catch was much more spread. The Superior Klondike strain is the only humper strain of lake trout stocked in the lake. Lake trout exhibit a high amount of ecomorphotypic variability. So one ecomorphotype of lake trout is the humper strain, or humper morphotype. This is from Lake Superior, and it is known to have a high amount of fidelity to various reefs or humps in that lake, hence the humper designation for that particular morphotype. By contrast, all the other strains stocked in Lake Michigan are of the lean ecomorphotype, which is the most commonly known ecomorphotype. This information can be useful for managers and stakeholders who can look at these different strains and incorporate this different potential for dispersal to achieve different management goals. Our second study objective was to determine the origin of lake trout harvested in different areas of the lake. So this figure shows the origin of hatchery lake trout caught in each district of Lake Michigan. We're looking on the y-axis at the percent of lake trout from each origin location, with 4 origin locations shown: the Northern Refuge in blue, the Southern Refuge in black, Julian's Reef from Illinois waters in green, and a compilation of near-shore stocking locations in orange. The first 4 columns show the origin of fish recovered in Wisconsin waters, and show that in northern Wisconsin, the Northern Refuge and Southern Refuge contribute the most amount of fish, while in southern Wisconsin, WM5 and 6, the Southern Refuge and Julian's Reef contribute the most amount of fish to the sport fishery. Illinois and Indiana show similar contributions as southern Wisconsin, with high amounts of fish caught from Julian's Reef and the Southern Refuge. Michigan waters is more of a mixed bag. We do see a lot of fish from the Northern Refuge contributing to the northern areas of Michigan, and a lot of fish from the Southern Refuge contributing to the southern areas of Michigan, but nearshore stocked fish form the bulk of the catch for many of the Michigan units. This is because most of the nearshore stocked fish in Lake Michigan occur in Michigan waters, and this is showing that those fish are fairly localized in their importance, but certainly are important to the catch in Michigan waters. So one of the big take-home messages from the prior slide is that offshore stocking sites are providing a large source of fish for nearshore areas, and these 2 maps provide another way of visualizing that. In both of these maps, we're looking at the percentage of fish recovered in each district that originated from a specific spot in the lake. The left-hand map shows the percentage of fish recovered from each district that were stocked in the Northern Refuge, highlighted in yellow. And the right-hand map shows the percentage of fish recovered in each district that originated from the Southern Refuge, again highlighted in yellow. So obviously these percentages don't add to 100% across the map, and that's because we're looking at the specific percentage of fish in each management unit that originated from the stocking location. I've highlighted in red font any number that's above 14%, and looking at those red values across the 2 maps, we see that the Northern and Southern Refuge combined provide a fair bit of fish to these nearshore areas. This pattern is likely due to higher offshore survival for lake trout. In this figure, we're looking at the catch per unit effort corrected for the number of fish stocked. So that accounts for different stocking numbers from different locations and can be interpreted as a measure of relative survival. And we see that Julian's Reef had the highest amount of relative survival in each of the 4 jurisdictions on Lake Michigan, while the Southern Refuge had the second highest relative survival, again, in each of those jurisdictions. So this is likely because those fish stocked offshore in their early life stage receive some protection from the fisheries and also are being stocked on what was historically important spawning habitat and is really high quality habitat for lake trout of all stages. The last objective of this study was to help understand the genetic origin of wild lake trout. So what genetic strains contribute to lake trout recruitment? This figure is the main take-home figure from a study that was led by our colleague Wes Larson, who was formerly at the University of Wisconsin-Stevens Point as part of the USGS cooperative unit there. And what this figure is showing is the relative contribution to wild recruitment from each of 4 different strains relative to the expected amount of recruitment based on the number of fish stocked. So that's where the movement data came in. The movement data helped to set what the expected recruitment values were by factoring movement in as well as stocking numbers to those expected observations. What we're seeing in this figure are each row representing a different region of Lake Michigan. And the warmer colors represent fish that contributed more to wild recruitment than was expected from stocking numbers, while the colder colors represent fish that underperformed relative to expectations. The main take-home points from this were that the Seneca Lake strain, the first column, contributed more than expected to wild recruitment of lake trout in Lake Michigan. The second column, the Lewis Lake strain, had contributions that were more or less on par with expectations, while the two right columns showing the Green Lake strain and the superior strains, which is actually three separate strains that were very similar genetically, having underperformed in terms of their contribution to wild recruitment in Lake Michigan. So from this, it looks like the two main contributors are Seneca Lake, which is from the Finger Lakes region of New York and has displayed some characteristics that result in less distributional overlap with sea lamprey, and the Lewis Lake strain, which was stocked in Lewis Lake, Wyoming using lake trout from Lake Michigan in the early 20th century, and thus is a Lake Michigan remnant genetic strain. In addition to assisting with this study on the genetics of wild recruits, these data have had several other applications. First, the movement data have helped determine stock assessment units in the non-treaty waters of Lake Michigan. The movement data has also served as an input to stock assessment models that are used to estimate population statistics and are used to help set harvest targets in line with what can be sustained by the fishery. Finally, these data have helped fishery managers evaluate the lake trout rehabilitation strategy by estimating the contribution of fish from various stocking locations to the fisheries and the dispersal potential of different genetic strains. Here are the main take-home points of our study on lake trout movement. Lake trout were usually recovered within 100 kilometers of where they were stocked, either in the stocking unit or in adjacent management units. Lake trout stocked near shore rarely crossed the lake and were localized in their importance. Lake trout stocked offshore at the Northern Refuge, Southern Refuge, and Julian's Reef provided sources of fish for nearshore areas and were recovered in a wider area around their stocking location. Dispersal was similar among genetic strains except for the superior Klondike strain, a humper ecomorphotype that rarely moved away from their stocking location. With that, I'd like to thank you all for your attention, and thanks again for tuning in today. I'd like to specifically thank a few members of the modeling subcommittee of the TFC, specifically Mark Ebner, Rick Clark, Steve Lennart, and Dave Carafino, for comments they provided throughout earlier stages of this analysis. If anybody has any questions about any of the material presented, please do not hesitate to contact me at the email address provided on this slide. Thanks again.